Kilo, Mike.
Kilo, November 4, WB2UJB.
Four stations, and I didn't copy any specifically. So the loudest one, take it.
Whiskey Bravo 2, Uniform, Juliet Bravo.
Whiskey Bravo 2, what's the rest?
Uniform, Juliet Bravo.
Uniform Juliet Bravo. Roger, what's the name?
Name here is Steve. Sierra Tango Echo Victor Echo.
Roger, Steve, and what's your location, sir?
I am in Aberdeen, Maryland, just outside the Aberdeen Proving Ground.
Well, in that area, I would certainly keep my head down, Steve. What radio are you running?
We're running a vintage radio here. We're running a Collins S-line, over.
A Collins S-line. Okay, what's the vintage of that radio?
What's the advantage?
No, what's the vintage? What year?
Oh, I'm guessing probably about 1964, over.
Roger, Roger. Now, tell me, does that radio have a compressor?
Negative.
Roger, Roger. Is that a quasi-military device?
No, not to the best of my knowledge.
Roger that. Does it have an ALC meter?
Yes, it does.
Roger, Roger. In our generic setup, not being able to use the compressor, but still looking to try to fatten you up a moment, if you were to consult your ALC with mic gain in hand, you would want to set that ALC meter for a mid-scale to 2/3 fluctuation on your ALC meter by manipulation of your mic gain control as you speak naturally into your microphone, maybe even counting 1, 2, 3, 4 as you adjust for that level, Roger.
Actually, I'm watching myself on a monitor scope rather than using an ALC meter, over.
Roger, Roger. Well, you know what we're talking about is a fattening process that will occur when you run your ALC meter mid-scale to 2/3 that you will not probably see on your meter. Now, we're not saying that you should have excursions beyond, into the red on the ALC. We would never want to do that, but we do suggest that you would be maximizing your dynamic range reduction by running that ALC meter mid-scale to 2/3. Roger?
Watching my scope and I'm watching the meter, and I'm roughly somewhere about half scale. On peaks, I'm probably going almost up to the top, over.
Yes, okay, and that's what's happening without the compressor, sir. Your dynamic range is about 10 dB. Which is a totally unprocessed signal. The human voice, if you were to look at my voice on a PA system and you had a VU meter attached to the output of the PA system with no processing, you would see that that meter would be fluctuating 10 dB dynamic range. Dynamic range is the difference between the least amount of sound my voice makes and the maximum amount of sound my voice makes. So 10 dB, usually they say a human voice unprocessed has a 10 dB dynamic range, which equates to a radio as a 30% average percent of peak modulation. Now, what we want to do normally is try to bring that up, that average percent of peak modulation up from 30% to around 80 to 85%. And to achieve that average percent of peak modulation, one has to be running around a 3 dB dynamic range, not a 10 dB dynamic range. And you would know the difference between those, Roger?
All I can tell is I'm looking at a scope, and I seem to be modulating pretty well here, and I'm not flat topping, and it seems to be fairly linear, over.
Yes, sir, it is extremely linear, and it is a 10 dB dynamic range. So what I'm saying, without some processing capabilities, you will be restricted to a 10 dB dynamic range, since you have no means of crunching that dynamic range down to a 3 dB as opposed to a 10 dB. Roger?
Roger. No, I've never run any processing on this. This is the way that the S-line was put together. It has a matching microphone which I'm using, and I'm also using the 30L1 linear amplifier, over.
Yes, sir. Yes, sir. Just so you understand that your average percent of peak modulation is 30%. Unprocessed audio that you're running is average percent is 30% of peak modulation, whereas the modern radio with the compressor and running the ALC mid-scale to 2/3 can come up with a 3 dB dynamic range with an average percent of peak modulation of around 80 to 85%. So the difference is from 30% peak modulation to 80 to 85%. Roger?
Roger. The end result is, though, there's nothing I can do about it. This is just the way it runs, over.
Oh, yes, sir. I understand that. I mean, you could get external processing equipment to go into your mic level and be able to bring that radio right up to modern standards as far as 80 to 85% of average peak modulation. But I'm sure that there is a certain enjoyment of operating a radio from times past. Roger?
Yeah, that's exactly what I'm looking to do here. I have no processing on here, and I really have no desire to put any processing on here, over.
Yes, sir. Yes, sir. And that certainly is commendable on your behalf. Only stating that when push comes to shove and you become involved in heavy noise, QRM or noise, your signal is not going to be perceived as well because your average percent of peak modulation is so low, as opposed to a signal that's coming in at 80 to 85% of peak modulation, which is probably sounds about twice your volume. Roger?
Roger, I understand that. I mean, that's why I got a linear on here to increase my output power, but I don't have any desire to change things in terms of putting an outboard compressor on. Over.
Roger. Now, I don't want you to get the wrong idea. When we bring somebody up through our generic setup, we start with a 3 on the compressor. A 3 on the compressor is something that you will never hear working. A 3 is not detectable as far as saying, hey, he's running a compressor. And we chose 3 for 2 reasons. One, it's non-noticeable, and the other thing is that it's part of the program to get to that 3 dB dynamic range to that 80 to 85% average peak modulation. But it's a matter of finesse, adjusting the radio with finesse that you can't hear anything working except it's just loud and no distortion. Roger?
Roger. I would appreciate, though, a critical evaluation from you with regard to how it sounds, and if you have a spectrum analyzer that you're looking at, I'd be curious to know if you see anything in terms of excessive bandwidth, over.
Well, now, my spectrum analyzer is in audio only. It's an audio spectrum analyzer, so it's not going to show me your actual fluctuations outside of the band. But, what I can say and what I can see is that your audio is mainly in the upper mids. There's nothing in the bottom end. There's no bass much at all. It's all in the upper mids. And if you would be interested, we are recording now, and we will be placing this up on YouTube in a couple of days. So if you go to YouTube and do a call letter search for Kilo Charlie 9 Victor Kilo Victor, that will take you to our Qso-Vlog page. And let me correct that. When you do the call sign search for KC9VKV, put the date on the end of that. It's KC9VKV 9/25/20, and that will take you directly to this recording. A lot of times YouTube used to put this on page 1 of our Qso-Vlog page, but now they're starting to bury it somewhere. So about the best way that you can get to this recording is do KC9VKV 9/25/20 on a YouTube search. Roger?
Roger. The microphone on here, I think, is actually a Turner microphone, that Collins OEM. It's actually an SM3 microphone, but I believe it was actually made by Turner. And the frequency response, I believe, is somewhere around the 300 to 2400. Over.
Roger, I'm seeing even to me it just looks like all upper mids, but you be the judge of it. And I would suggest that you get a windscreen, a foam windscreen for that mic that will cut down on wind noise turbulence from your voice. You know, like plosives and just general things that come out of your voice that aren't words. Roger.
Roger. There is a windscreen that's built into the microphone. Over.
Yes, sir, but the problem is with those internal windscreens is that you still have a mic grill work in front of that windscreen. And what happens is these transient things that come out of your mouth get channeled in those in that grill work, you know. So what you actually want to do is get a foam windscreen that fits over the whole thing that can disseminate these wind plosives before they even get to the grill work. Roger?
Roger.
So, gosh, let me, Steve, is that the name?
Yes.
Yes, sir, Steve. It's been a pleasure. It's past my bedtime. I'm starting to turn into a banana, or I forget exactly what it is. Oh, pumpkin. I turn into a pumpkin at 5 o'clock. Roger?
Roger, I didn't get your name. Over.
Yes, sir. Steve, my name is Jim, Juliet India Mike. This is KC9VKV. We are located just across the Ohio River from Louisville, Kentucky. We're on the Indiana side of the Ohio River, right at Louisville. Roger?
Roger, I didn't give you a signal report. You're about a 5x6 or 5x7 here in Aberdeen. Over.
Roger. Well, usually we're shooting for 20 overs. Sometimes we fall short of the mark, unfortunately. Roger?
How am I doing out by you? Over.
I'm copying you on my local antenna, and it looks like your RF signal is, I can't give you an actual S-meter reading because my receiver, I've got it tuned down RF-wise, so I'm not into AGC compression, so I can get the best possible recording. So what I've got is a VU meter tied to the output, and I adjust your voice on the VU meter for 0 level, and then when you cease speaking, the meter falls down and is then reading the ambient noise level. And so when you, I've got you calibrated for 0 level, and when the meter falls down, you're somewhere around minus 15, minus 20. So you have an exceptionally good RF signal. Roger, 20 dB above my noise level.
Very, very good. Nice to hear. Well, I appreciate your critique. I'll let you go. And it was nice talking with you, Jim. So, KC9VKV from WB2UJB. 73, Jim.
Roger there, Steve. And again, as you look at, if you get a chance to go by YouTube and do a call letter search for KC9VKV 92520, that will bring up this recording, and you be right at the end of it if you wanted to skip down to that. But there's a lot of stuff that we've followed today in getting to here that you might find interesting. So I would actually start at the beginning of the recording. Threes to you, Steve. Have a great afternoon. Roger.
Roger. Thanks again, Jim. Take care. 73.
Roger. And this is the end of our transmission for today. We've enjoyed it much. If you have participated again and want to check out your audio, if you go to YouTube and do a call letter search for Kilo Charlie 9, Victor Kilo Victor, followed by today's date 9/25/20, that will take you directly to this recording. So that'll do it for us now, and we will be returning this frequency to normal amateur radio use. This is KC9VKV Clear.